Natasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of multiple integrals, right? So let us begin with the topic named change of order of integration. So sometimes evaluation of the double integrals become easier by changing the order of integration. So to change the order of integration, first we have to draw the region of integration with the help of given limits. So whatever are the limits, using it we will draw our region R. Then what we will do? We will draw our vertical or horizontal strip as per the required order of integration, right? And on changing the order of integration, the limits of integration will also change. So from this what we have studied, whenever we are given double integration over R f of x comma y dx dy, right? Then we can change the order of integration, that is we can solve using double integration over R f of x comma y dy dx using the following steps. That is, firstly we have to draw the region R, then according to the given limits we will draw our vertical or horizontal strip and then change the order of integration and change the limits of integration. Okay, so now let us start one example. So we have to change the order of integration and evaluate integration 0 to infinity, integration x to infinity e raised to minus y upon y dy dx, right? So let us start with the solution. Here we are given firstly the limits of y which are varying from x to infinity, right? And the limits of x are varying from 0 to infinity. So using these limits, let us draw our region R. Okay, so firstly let us draw x is equals to 0. So this is your y-axis. Okay, next x is equals to infinity. So it will be your this portion, right? Now y is equals to x, that is your line y is equals to x. So this is your line y equals to x. And lastly you are given y is equals to infinity. So it is your this part, right? So from this you can see the region of integration R is this portion. Okay, so this is your region R. Now we are given our vertical strip, that is y is going from x to infinity, right? So now we have to change the order of integration and move this vertical strip to our horizontal strip. So changing the order of integration and drawing our horizontal strip PQ. So now we have changed the order of integration and now our limits will be from x is equals to 0, which is starting from P and will end at Q, that is x is equals to y. Okay, and our limits of y are from 0 to y is equals to what? Infinity. Okay, so these are your new limits. Now our question is integration 0 to infinity, integration x to infinity, e raised to minus y upon y dy dx, right? So now we have to first put the limits of x, right? Because it has variable y. So put the limits of x, they are 0 to y dx. Now put the limit of y, that is 0 to infinity, and dy, and your function is e raised to minus y upon y. Okay, so now let us start the integration first with respect to x, keeping y as constant. Okay, so this term integration 0 to infinity dy will remain as it is, and since y is constant, e raised to minus y upon y also will remain as it is. Just we have to do integration from 0 to y dx. Okay, now we know integration 1 dx will be equals to x and your limits are from 0 to y. Now suppose if you put the limits, then you will get what? Y minus 0, right? So you will get your answer as y. Now these two y will get cancelled out. So finally what will remain? Integration 0 to infinity e raised to minus y dy. Okay. Now do integration of this with respect to y using the formula integration ax dx. You will get your answer as what? E raised to ax upon a. So integration of e raised to minus y will be what? E raised to minus y upon minus 1. Okay, so here take this minus in the numerator. So you will get minus e raised to minus y and the limits are 0 to infinity. Okay, now let us put the infinity, but firstly take out minus common. So you will get minus. Now put limit as infinity. So you will get e raised to minus infinity minus, put the lower limit. So minus e raised to 0. Now we know e raised to minus infinity is equals to 1 upon e raised to infinity. But this goes to what? Infinity. So we will get 1 upon infinity. So the final answer of e raised to minus infinity is 0. So this term will go to 0 and e raised to 0 is 1. Minus minus plus. So the final answer after changing the order of integration will be equals to what? 1. Okay. Now let us solve one more sum. Here we have to change the order of integration and evaluate double integration from 0 to a, y to a, x upon x square plus y square dx dy. Okay, so let us start with the solution. So here we are given firstly the limits of x and they are x from y to x is equals to a and your limits of y are 0 to a, right? So let us draw all the four lines and form our region R. So firstly let us start drawing x is equals to y. So this is your line x is equals to y. Okay, next draw the line x is equals to a. So this is your line x is equals to a, right? So from these two lines, firstly we will find the point of intersection between x is equals to y and x is equals to a. Suppose you put in this, what we will get? Y is equals to a. So your point of intersection is what? A comma a, which is shown over here. Okay. Now we have to draw y is equals to 0. But this is your x-axis, right? And y is equals to a, right? That we have already taken over here because in the point of intersection we have our line y is equals to a also, right? So no need to draw that. Now from the intersection of all these lines we can say that this is our region R. Okay, and we are given our horizontal streak, that is from x is equals to y to x is equals to a. Okay, so now we will change the order of integration by moving this horizontal strip to a vertical strip, right? So on changing the order of integration and drawing our vertical strip PQ, right, our new limits will be y will vary from 0 to x. Okay, so y varies from 0 to x and our x will vary from 0 to a. Okay, so you have seen that we have changed the order of integration, that is we have moved this horizontal strip to the vertical strip PQ. Okay, so now our question is given as integration 0 to a, integration y to a, x upon x square plus y square dx dy. Right, this is our given question. Now let us change the order and put the new limits. So here firstly we will put the limits of y because it consists of the variable x. So firstly let us put 0 to x dy, right? Next put the limits of x, they are 0 to a and dx. Put your function, that is x upon x square plus y square. Okay, so you can see from here we have changed the order of integration. Okay, so let us evaluate the integral by firstly integrating with respect to y, keeping x as constant, right? So this x as constant, keep it as it is, and integration 0 to a dx will also remain as it is. Just we have to evaluate 1 upon x square plus y square dy, where our x is constant. We know the formula of this integration. It will be equals to what? 1 upon a, but here a is x, so it will be equals to 1 upon x. Tan inverse, what will come? Y upon x, right? So 1 upon x, tan inverse y by x. Now these two x will get cancelled out. Now let us put the limits, right? So integration 0 to a dx as it is. Firstly put x in place of y, right? So x upon x will give us answer 1. So finally we will get tan inverse 1 minus. Now put the lower limit. So you will get tan inverse what? 0. Now we know the value of tan inverse 0. So it is 0, right? So it is gone. Now the value of tan inverse 1 is what? Pi by 4. So take that outside. So finally integration will be from 0 to a dx. Now we know that integration 1 dx will be equals to what? X. And the limits are from 0 to a. Now put the limit. So you will get your answer as pi by 4 times a minus 0. Right? On simplifying, final answer after changing the order will be equals to what? Pi by 4a. Okay? So in today's session, what we have studied? Changing the order of integration. Very important topic. Right? So whenever you are given double integration over R, f of x comma y dx dy. So here firstly we have to integrate with respect to x and then y. So on changing the order of integration, that is firstly you have to draw our region R from the given limits, then draw your horizontal or vertical strip. Suppose you are given horizontal strip, right? Then you have to move it to a vertical strip and do vice versa procedure and change the order to double integration over R f of x comma y dy dx. Okay. So I hope you have understood throughout the session. Thank you for watching.